Now let's talk about mutate function. So what it does, it creates a new column from existing column. So suppose in this data frame, suppose we have these two columns like those 1 and those 2, and you want to create a new column called sum, and you say that which is nothing but those 1 plus those 2, then it would create the sum. And in our case, in our H-flight data set, suppose we want to create a new column called loss, which is nothing but arrival delay minus departure delay. So it would automatically create this loss new column. So using that mutate function, let me quickly go through the demo first. So suppose we are using mutate function, and on top of which data? H-flight's data. What we want to create? We want to create a new column which is actual ground time. And now first let's create the loss column first, which I showed you in the PPT. Then we'll come to this. So suppose I want to create loss. So loss is nothing but your arrival delay minus departure delay. So let me create that arrival delay minus departure delay. And suppose you created this. So G2 is new table which is being created, and there will be a new column called loss. And as you can see that arrival delay minus 10 minus departure delay minus 0 is equal to minus 10 minus 9 minus 1 minus 10. That's how it can create. And similarly, I have created another column which is actual grounded time. So from actual elapsed time minus arrival time. So this is total time, and this is total time in air. So if we subtract it, so we can understand how much was the ground time, how much time the flight was on ground. So you can see this is the new table which is G1. A new column is being created which is actual ground time. So that's how you can create lot of new variable from your existing data, which would actually help you in feature engineering. When we will be discussing about feature engineering, you would understand these function would be very much useful. And I want to also give you the hints like how even if you don't know deep layer function, deep layer package, then how do you do it? Then we had the old method H-flight $actual grounded time, and which is nothing but H-flight actual elapsed time minus actual air time. So that's how we would do it. So here benefit is we are using a function and we don't need to call this H-flight again and again. Instead of that, we can simply call this function, and that will do our job. Now let's discuss about filter function. So what it does, so it pick observation. So observation is nothing but row. So it pick row by their values, and you can pass a lot of different kind of conditional statement that how you want to choose these rows. So suppose here you have suppose talk about this one which is about the H-flight. So on H-flight data, you want to take only those rows where the flight was cancelled. So this cancelled equal to 1, that is your logical test, and you are asking give me all those rows where the flight was cancelled. So instead of this equal to, you can also use all these function greater than, equal to, not equal to, less than, equal to, all those things as well. Let me quickly go to the demo first. So this is about filter specific rows which matches the logical condition, and these are the R comes with a set of logical operator that you can use inside a filter, like X less than Y, less than equal to Y, equal to Y, not equal to Y, greater than, and all those things, right? Now suppose you want all the flights where the distance was more than equal to 3000, and you want to name it as long flight. If you want to see the long flight, you would see what was the condition? The condition was distance is more than 3000. Now if you go to this distance column, where is that? Yeah, this is where the distance column is. Now if you see this distance column, all of them are more than 3000. But if you remember earlier our total data set was more than 21,000 something, right? But if you want to see the glimpse of it, suppose you want to see the glimpse of this long flight, then you would see how many rows we have, only 527. So as you can see, it can filter it out and give you the result based on the condition you pass. Now similarly, you can create lot of different condition and you can access those rows. Like there are a lot of example, but let me give you a couple of them. Suppose you want to understand all the flights where taxing in and taxing out takes more than the flying. So you had to wait there actually. So what I am doing, so I am saying using filter function, give me all those rows in each flight where the taxing in plus taxing out is more than the air time. So let me create that long journey, and if I try to see this, where is my air time? This is my air time, which is 42. And if you see the taxing in and taxing out, if you add, it would be more than 42. Similarly, if you add 40 plus 10, 50, which is again more than air time. So it would give you only those rows where the condition is met. Similarly, you can use lot of funny stuff, and you can see it like this one is all the flights which departed before 5 am or arrived after 10 am. So I am saying departure time less than 5, or since it has written or, so that's why I am saying or arrive after 10 am. So I can create, and you can check all the flights that departed late but arrived ahead of schedule. So the arrival delay would be definitely less than 0. It would be negative. That's how I am saying that this arrived ahead of schedule. And there was departure delay was something more than 0. That's how I can say that it departed late but arrived earlier. So is there any flight? So you can quickly check the glimpse by glimpse. So it works like the str function, and you would be easily understand that how many rows are there. So if you see, and then you can understand how many rows are there. So there are, okay, so lot of observation are there, like 27,712 where there was some delay, but ultimately it reaches before time. Now similarly, all the flights that were cancelled after being delayed. So cancelled is equal to 1, but again departure, there was some departure delay. You can again see using that glimpse function how many rows are there, like how many weekend flights flew a distance of more than 1000 miles but had a total taxing in time below 15 minutes. So it was a long journey, but you did not have to wait with that taxing in and taxing out. So you can similarly create. But now see, it asks about weekend flights. So the day of week should be either 6 or 7, Saturday or Sunday. So that's how I am creating that or. And then I am saying the distance should be more than 1000 miles, the next condition. And the third condition is taxing in plus taxing out should be less than 50. And that's how you can create, and you can see the number of rows. Yeah, instead of glimpse, you can use n row as well, like we learned in data frame, n row and n column. So how many rows are there? 1739. And you can use these function as well instead of these or, which we will be discussing the pipe function later, and you would be getting the same result. Yeah. Now let's quickly understand the arrange function. Let me first go through the slides. Filter is done. Now arrange. So what it does, so it arrange your rows based on some condition you pass. So suppose you say that arrange all the flights based on the delay. So you had a column called departure delay. Those can be negative, those can be positive, and few of them it's like 0. But you can arrange them. So by default arranges the rows from smallest to largest, like increasing. But rows with smallest value of the variable will appear at the top of the data set. You can reverse this behavior with decreasing order using that decreasing function. So let's try to understand with a demo. So as I said, arrange function is used to reorder the rows according to a single or multiple variables or multiple condition you have. Now, so we are first taking all those flight where the flight was cancelled, and for departure delay at least there is not a NA value. So we are checking if the departure delay column consists of any NA values, then we will not take that. At least we need some positive, negative or 0. So first we are taking and storing it in DTC. You can see the DTC glimpse of DTC as well. Yeah, there are only 68 rows like that. Now what you are doing, you are arranging them. So you are arranging these 68 rows by departure delay. So first you can see the DTC here. Let me show you first the DTC. As you can see, 68 observation, 21 variable. So only 68 observation. Now you can arrange it by departure delay, and then you can let me show you the D here. Yeah, so where is the departure delay? Yeah, so as you can see, now it has been arranged from smallest to highest. So -10, -9, -8, like that you can see all the delay. Similarly, if I say now I want to arrange it by cancellation code, so arrange DTC so that the cancellation reasons are grouped. Now if I see this, again 68 observation, but now this has been arranged. And what was the arrange by cancellation code? Yeah, so as you can see, A start with A, then B, then goes to C. That's how it has been arranged. Now by default this arrange function arranges rows from smallest to largest, but as we discussed, you can reverse it using this decreasing order. So you can use this function decreasing, and then instead of increasing you can arrange it by decreasing order. So let's do the same thing that you want to do it. So suppose remove this one unique carrier. Suppose you want to arrange it by departure delay, but now this time by decreasing order. And suppose you want to store it, then decreasing flight, suppose. And if you want to see this decreasing flight here, your departure delay, here is your departure delay, and now you can see the departure delay is now largest to smallest. That's how you can see it. Yeah, this is departure delay 981, 700, 500, 400. That's how it's been done. And similarly you can do this arrange flight by total delay. So you can pass this also, like you don't need to separately write another column. So you can pass the summation, and that you are saying that arrange it by total delay, which is arrival delay plus departure delay.